The topic of this FRQ is going to be modeling rates of change, specifically related rates. This will be from the AP Calc AB exam from 2002, specifically Form B, and it's free response question number 6 by Thomas Tran and Casey Cruz. This is the full problem we will be covering. You can read the entire problem or all the stuff they give you and also see the display and the full parts that we will be going over in the next couple slides. Remember to read this fully, and you can refer back to this to see the whole problem during the video. Okay, for this question it is discussing two ships and their path of travel in relation to a lighthouse rock. Ship A is traveling due west towards the lighthouse rock at a speed of 15 kilometers per hour, while Ship B is traveling due north away from lighthouse rock at a speed of 10 kilometers per hour. Let X be the distance between Ship A and the lighthouse rock, and let Y be the distance between Ship B and the lighthouse rock. Okay, so it tells you to find the distance in kilometers between Ship A and Ship B when X equals 4 and Y equals 3. This is fairly simple, as this is a right triangle. So when X equals 3 and Y equals 4, and they're asking for the distance between Ship A and Ship B, really what you're finding is this, which is the hypotenuse. So you just do the Pythagorean theorem, 3 squared plus 4 squared equals, let's call this C squared. 9 plus 16 equals C squared. Square root of 25 equals C equals 5. So the distance between Ship A and Ship B is 5, and you want to make sure to use units. The unit is kilometers, as stated in the problem. So that is your answer. Okay, for part B, it's asking us to find the rate of change in kilometers per hour of the distance between the two ships when X equals 4 kilometers and Y equals 3 kilometers. Remember, this is a Pythagorean theorem problem because it's a right triangle. We're going to use r squared as the hypotenuse, or r as the variable for the hypotenuse. Remember, x squared is the distance between the lighthouse rock and Ship A, and y squared is the distance between lighthouse rock and Ship B. And r is the distance between Ship A and Ship B. So first you want to isolate the r variable by squaring both sides, or square rooting both sides. Next, you want to derive both sides, so dr over dt equals, remember, this is x squared plus y squared to the 1/2. So the derivative of it is 1/2 times x squared plus y squared to the negative 1/2 times chain rule, remember chain rule, 2x dx over dt plus 2y dy over dt. 1/2 times, now you want to plug in the numbers to find your dr over dt, or the rate at which the distance between Ship A and Ship B is changing. So your x value is 4, it says, and your y value is 3, so to the negative 1/2 times 2 times 4 times your dx over dt, which is, since it's saying Ship A is traveling due west, it's heading towards the lighthouse, so the distance is getting shorter. So you want to make sure that since it's getting shorter between the lighthouse rock and Ship A, it's a negative value. So it's times negative 15 plus, remember to put 2x dx over dt in one parentheses, in that sort of parentheses, larger parentheses, because you know PEMDAS, and 2 times the y value, which is 3, times dy over dt, which says it's heading 10 kilometers an hour north, meaning the distance is increasing for y, so this value can be positive. Then you just got to simplify all this. 1/2 times 25 to the negative 1/2 is really 1 over 2 times 1 over 5. So it's 1/10 times 2 times 4 times negative 15 is negative 120 plus 2 times 3 times 10 is 60. Negative 60 times 1 over 10 equals negative 6. And remember units. Units you need to remember. It states right in part B, the problem, that it's kilometers per hour. And that will be your final answer. Negative 6 kilometers per hour equals the rate at which the distance between the two ships, ship A and ship B, is in this case decreasing because it's negative. Part C is asking us to find the rate of change of the angle, or theta, which is right here. LR is Lighthouse Rock, ship A, ship B. R is distance between ship A and ship B. It's asking us to find the rate of change of theta, or the angle right where ship A is, in radians per hour when x equals 4 kilometers and y equals 3 kilometers. So, using SOHCAHTOA, and since you're given x and y values, you could say tangent, because opposite over adjacent, tangent of theta equals y over x. Then, when you derive this, you get secant squared theta, remember that's the derivative of tangent, d theta over dt equals, remember high d low minus low d high all over low squared. So dy over dt x minus dx over dt at y all over x squared. And then it says at x equals 4 and y equals 3. So when x equals 4 and y equals 3, secant of theta, or really 1 over cosine of theta, equals 5 over 4. Because if you look at it this way, cosine of theta is opposite over hypotenuse. So opposite is y, which is 4, over hypotenuse, which is 5. But since it's secant, it's 1 over that, or basically you just flip the numerator and the denominator to get 5/4. So secant squared 5 over 4 squared d theta over dt equals, and then plug in all the values you have. Remember, dy over dt equals 10 times x, which equals 4, minus, remember, negative 15 because the distance is decreasing between ship A and the Lighthouse Rock, times 3 for y, all over x squared, and x is 4, so 4 squared is 16. Then, once you simplify that, 10 times 4 is 40, minus negative 45, which is really adding 45, all over 16, which equals 85 over 16. And then remember, you've got the 5 over 4 squared on the other side, so you have to divide by 5/4 squared, or really 85/16 times 16/25. You can cross out the 16s. 85/25 equals 17/5 simplified radians per hour. Radians per hour, or as I abbreviated, RAD period /HR. You want to remember to always put units. So your answer will be 17/5 simplified.